Welcome all to lecture 17 of subsurface exploration techniques and importance that technique involves. So, in today's lecture we are going to discuss more precisely about what are the methods when we go for sampling, particularly in offshore environment, and geotechnical investigations. If you remember correctly, when we were discussing about onshore geotechnical investigation, like the methods we used for geotechnical investigation on land masses, we generally go for standard penetration test, cone penetration test, dilatometer test, pressure meter test, and many more. Then when we highlighted also about what are the requirement for offshore investigations. So, the first slide mainly targets for what are the topics we had covered more specifically with respect to offshore investigation. So, in the first presentation, I tried to give you an introduction about offshore environment, starting with the continental drift theory, then different layers of the earth, then owing to the origin, owing to the processes which were responsible for creation of different mediums, or how the present configuration of earth in terms of major continental plates or oceanic plate has come into picture, what are the driving forces there. Then, as I mentioned, because of varying rate of weathering as well as deposition, the process of sediment deposition and erosion keeps on happening. So, that is why you can see change in the topography, change in the elevation differences as well. Then I told more precisely when we came to offshore investigation, the way there is change in the topography, there is change in medium characteristics between the continental plate as well as the adjacent oceanic plate. So, at times it is gradual change, at times it is very steep change, depending upon what are the governing processes dominating at that particular interface between continental plate as well as oceanic plate. Secondly, depending upon the thickness of each of those plates at the interface and the characteristics of the medium which are available at the interface, that is going to govern whether it will be a gradual change or whether it will be a very steep change between the oceanic plate as well as the adjacent continental plate. Then we also discussed when we gradually move from continental plate to oceanic plate, there will be continental margin, there will be shelves, then possible location where you can actually get high chances of oil and mineral depositions, which are called generally continental margins, based on which people over the period of time started exploring those, because throughout the earth there are a significant proportion of continental margins available, which are possible location for oil and gas as well as mineral depositions, and which of course when we go for detailed investigation or exploration of those kinds of minerals and oil, we have to go for specific structures which are particularly oil rigs and so on and so forth. So, in order to design those, we have to go for detailed investigation. So, we had discussed that like what are offshore environments, why there is a need you go for offshore environment, particularly related to oil and gas exploration. Then I also mentioned, in addition to these two primarily objectives, nowadays we also see like laying of pipelines along the sea floor, then telecommunication cables also laid at the sea floor. In addition, nowadays people are using sea floor as sea environment as particularly for erecting wind turbines, as well as for creation of artificial islands, support ports, so on and so forth. So those highlight what are the necessities when you go for offshore environment, because accordingly depending upon what kind of projects you are targeting, you have to go for detailed investigation, whether it is related to suitability of material, particularly for creation of islands or airports. Nowadays people are going for offshore environment in which you can actually create airports also, and bridges also. Now we are seeing across the globe like lot of bridges which are constructed onshore, offshore in the sea. So, what are the investigation to be done? Very much similar to onshore, but because there is change in environment, particularly there is water available beneath the load bearing stratum and the surface from which you are able to do the test. So, there are some challenges. Then in comparison to land mass, of course, the sea floor are not that detailed investigated for small projects. So, only in case of a very detailed project people go for sea floor investigation. So, what are the need for investigation? We had discussed like why it is required to go for offshore investigation, whether it is for laying of pipelines or construction of support ports, or maybe erection of wind turbines, or maybe setting up jack-up platforms or oil rigs. You have to go for detailed investigation onshore. Then we also discussed what are the application of offshore investigations, what are the challenges involved. We discussed like depending upon the characteristic of seabed material, depending upon the air bubbles which are entrapped in between the sediments or between different layers of sediments below the sea floor. Sometime it can lead to blast, sometime it can lead to release of poisonous gas, subsequently lead to deaths also. Then possible sand dunes, movement of sand dunes, then calcite depositions within the at the sea floor, which is happening at variable rates, and depending upon the binding characteristics of the calcite, it is going to govern what is the strength characteristics of the subsequent or adjacent seabed material which has been deposited or which has been densified. So, depending upon the characteristics of that particular calcite, which is responsible particularly for binding that particular seabed material, it is also governing the strength property of that material. Then owing to particularly water waves, water currents at shallower depth as well as deeper depth subsequently, and the suspended load in water, sea water, that will govern your sand dunes depositions, weathering, erosion and so on. And depending upon the height of the sand dunes, sometime it can load or provide immense pressure on the foundation of any existing offshore structure, which can lead to even failure of the foundation, or it can lead to it can lead to bearing capacity failure, or it can lead to settlement failure as well. So, what are the challenges involved? We had discussed in terms of stability, because finally it's not only about the resistance the seabed material is offering against external loading, but it is also the characteristics or the environment which is created at the seabed, whether it is related to ridge, whether it is related to shell, whether it is related to continental margin, and again depending upon what kind of what is the extent of water depth, what is the characteristic of seabed topography, seabed obstacle, it can induce more and more challenges which are to be highlighted, which are to be understood, which are to be clearly assessed before we go for actual erection of the or laying of the foundation tentative for the proposed structure. So, that is like challenges has to be highlighted here, we had discussed. Then we went for geophysical investigation, which are particularly used for two characteristics understanding. One is like determination of water depth along your study area. Of course, if you are talking about laying of pipelines, then your study area will be along a particular route. Second thing, if you are going for detailed oil and mineral exploration, you have to go for surveying a larger area, but it will be the dimension will be comparable in both the dimensions, like length and width of the study area, which makes it completely different from your investigation which is done for pipeline laying or design of support system for pipeline, transmission cables and so on and so forth. Again, whenever based on your preliminary investigation, if you find there are possible faults, so your anchor system should be designed such a way like any possible movement along the fault, it should not fail. In case you cannot avoid the placement of anchor on that fault alignment. So accordingly, the location of those water depth, sediment characteristics and obstacles, or may be possible unconformity or faults which are available on the sea floor, that can also be measured or can be determined based on geophysical investigation. More precisely, we discussed about echo sounding method, in which you are actually transmitting a sound into the sea environment, and then depending upon the time for reflection you get an idea what is the water depth. And same way, if you know your sensor is at a particular depth with respect to the base of the vessel, you can actually deduct it and get an idea about how much will be the true water depth, deduct or increase depending upon what is the relative position of that receiver with respect to the sea surface. And then obstacles, it is not only about the change in topography, but it also depends upon what kind of obstacle which may be temporary or which may be permanent at your site of investigation. So, all these things like water depth as well as obstacle present on the sea floor were the prime objectives when we started about geophysical investigation. So, those are the topics particularly related to offshore environment which have been covered so far. In today's class we will be discussing more precisely about sampling and in a very brief how the geotechnical investigations can be done in offshore environment. So, in order to assess the nature of seabed material in terms of strength as well as suitability for a plant structure, we all know like when we were doing onshore investigation, I told like it is always desirable because it is always desirable to go for more than one test. It can be combination of geotechnical, geophysical test, or it can be only geophysical test or can be geotechnical test, because some methods may give you very good result in case of dry soil, some will give you very good result in terms of rock medium, some may give you. So, depending upon the medium characteristic, one method may give you very good result, but there might be limitation in terms of maybe more precisely because you are not getting sample in most of the geophysical methods. So, in addition to geophysical method, you also go for geotechnical method. But when it comes to offshore investigation, as I mentioned earlier also, like offshore investigations are very much costlier. So, before going for detailed investigation, that is collection of sample. So, collection of sample means your vessel is there and considering the water depth which can vary from few meters to maybe 100 meters or more than that. So, whenever you go for any kind of sampling, you have to consider minimum that particular depth of water, after which only the seabed starts. So, any sampling means minimum that particular depth you have to pass or you have to cover before you actually start any kind of drilling or sampling operation. So, that makes geotechnical investigation in offshore environment quite cumbersome, challenging, as well as in comparison to geophysical investigation, those are manifold costlier. So, unlike onshore, when we go for geotechnical and geophysical investigation parallelly, in order to get more confidence, in order to get soil sample and similarly some other reasons, in offshore investigation we go for geotechnical investigation. Once based on your geophysical investigation, we find like the site requirements are very much positive or supporting the site selection for the particular project. Then now we can go for detailed investigation. So, we can put whatever investigation cost I mean to be put there. So, that is one thing. So, this way once you go for geotechnical investigation, the primary objective is to understand the nature of seabed material, what kind of seabed material is available. So, nature means in terms of what kind of soil is there, in terms of its strength characteristics. Of course, based on your strength characteristics, you can also get an idea how safe the proposed foundation will be considering the design life of the structure, whether it can be pipeline foundation, whether it can be mobile foundation for floating structure, or it can be fixed foundation. So, all those things will tell like how suitable the particular kind of foundation for plant superstructure or offshore structure. Then second, when we go for geotechnical investigation, we also plan to assess soil type for possible foundation option. What are the possible foundation option which are suitable considering the soil type which is available at the sea bed, or it can be at deeper depth also, depending upon what is your depth of exploration. Then third one, geotechnical investigations are also likely to give a clear indication what kind of challenges which can be which can be witnessed by laying the foundation. That is how you can be prepared in advance for those kinds of challenges. So that because as I mentioned earlier also, that like in unlike onshore investigation, where you can depending upon the nature of the challenge, you can at times alter the choice of the foundation or maybe the investigation method. But in case of offshore, it is highly undesirable because the construction cost or investigation cost will be significantly higher, or the penalty will be significantly higher. So, it will be very favorable if we can identify what are the challenges which are involved or which are possibly to be encountered during laying of the foundation. One example is like if you find some local material which is available beneath the or maybe a particular obstruction, which is though obstruction, but it is available at certain depth below the seabed. So, if you do not consider that into account, maybe while laying the foundation or while designing, you design the foundation based on your geophysical investigation data, but once you start laying the foundation and if you find some kind of obstacle which is kind of foreign material in nature, which is like maybe some kind of shipwrecks or some other thing which cannot be used as direct load bearing medium and has to be removed. So, if that consideration has not been accounted in your design part, that will of course lead to some kind of challenge or difficulty while laying the foundation. So, those kinds of challenge, it is like very much similar to some buried object in case of onshore. So, same thing if you are having in case of offshore, that will again impose more and more challenge to your medium, because finally this particular medium in which you are having some buried object is going to contribute or is going to provide resistance to your external load or overcoming load. So, in case if it is not properly addressed, it can lead to challenges or it can lead to difficulty, or subsequently it can lead to penalty or significant change in your execution cost. And then next, almost avoid any kind of modification, because whatever the challenges are likely to be occurring, you have taken all those into account. So, you after those challenges you must have explored all possible types of foundation and what are the challenges if you go for those kinds of foundation, whether in terms of money involved, whether in terms of depth of exploration required, whether in terms of the type of foundation to be provided, whether in terms of infrastructure or machinery which is required for laying any kind of foundation, suitability or availability of those kinds of machines. So, almost you can avoid all possible modification chances which are to be done at later stage, because again those will be proven very expensive. And the last one, of course, whenever we are going for identification of problematic soil, whether we are targeting for identification of any kind of buried structure, whether we are confining to any particular foundation type amongst many possible options, the overall objective is to ensure the safety, because again very much similar to investigation cost, the construction cost of superstructures, the overall cost of the superstructures, whether it is exploration rigs, it will be significantly higher. So, you cannot compromise the safety of the structure unless its design life is over minimum. So, that all indicates like you have to go for geotechnical investigation, whether it is related to the choice of foundation, whether it is related to identification of problematic medium which is available beneath subsurface, in order to forecast any possible change which is possible during laying of foundation or at later stage, which can compromise the resistance offered in its in situ condition with reference to the design criteria, or in order to ensure the safety of the structure during its design life. You have to go for detailed investigation, but repeatedly I am telling, when we go for geotechnical investigation, it has to be done after based on your preliminary investigation as well as geophysical investigation, which is suggesting your site selected for detailed investigation is very much meeting your requirements for the project, unless there is no point in going for detailed geotechnical investigation. So, when we go for planning of any geotechnical investigation, first of all we have to start like others discussed surveys. We have to go first of all go with preliminary investigation, which starts with exploring what are the available reports, which talks about maybe the soil type, maybe topographical information, maybe geological information, maybe geomorphological information, or maybe some kind of challenges, some kind of forensic investigation done at the proposed site or in its environment or adjoining sites in the past. So, that is going to give you confidence about your site selected even before going for any kind of investigation. So, that means you know your site based on your existing literature without spending much on detailed investigation, and based on that you can possibly select most suitable method for detailed investigation. If you find like your site is suitable for going for detailed investigation, whether it is geophysical or geotechnical, then so based on reports you can have, based on maps also you can check, based on published data. Lot of time because of maybe environmental issue, maybe because of ecological issues, maybe because of seismic issues, geological issues, or maybe meteorological issues, people do lot of surveys offshore even for construction of important structures, particularly nuclear power plants, though it is not offshore, but because in order to ensure the safety of such structures, if available near to your sea environment, people go for detailed investigation offshore. So, such kind of literature, whether in terms of report, whether in terms of published data, if it is available, it is advisable to go through these reports before going for detailed geophysical investigation, because already lot of money by that particular agency has been put in the past for investigation related to your site itself. Then we go for so after preliminary investigation you go for shallow geophysical method, which precisely consists of echo sounding as we discussed about, and bathymetry for water depth determination as well as for mapping of sea floor and possible obstacle available on it. This will also provide how suitable it is to go for detailed geotechnical investigation. So, this is possibly an indication, like preliminary investigation gives you an idea, you can go for which method of geophysical investigation, whether it is required or not to go for geophysical investigation, and collectively based on your preliminary and based on your finding from geophysical survey, you can plan for detailed geotechnical investigation. Remember, in comparison to geophysical investigation, geotechnical investigations are manifold costlier. So, there is very important decision making required before you go for detailed investigation, because once you do detailed geotechnical investigation, you have to arrange assemblies which are required for deeper drillings, maybe sampling and interpretation, and everything most of the time is done nowadays at the site itself. So, it is not like you are collecting the sample, bringing it to your onshore laboratory, testing it. No, everything is done onshore, because at times you are doing the testing maybe 50 kilometer, 80 kilometer within the sea. So, it will be highly uneconomical to collect the sample, bring it into the onshore laboratory, do the test, and then go for next exploration. So, everything is done there itself, based on the kind of again based on the kind of infrastructure which is available or the vessels which are involved in detailed investigation. Then we start with shallow geotechnical survey, which depending upon the water depth, which depending upon what kind of structure you are planning. So, particularly for laying of pipelines, you need not go for very detailed investigation, because of course, the load distribution of such kinds of pipeline will be limited to maybe few meter depth. So, you can go for a shallow geotechnical investigation. So, this consists of collecting soil sample from few meters below the seabed, because that will be the medium which will be acting as a load bearing medium. So, when that in shallow geotechnical survey, you can actually collect the soil sample from those particular depth which are acting as a load bearing stratum, examine them in terms of properties, in terms of strength characteristics based on laboratory investigation, generally used for offshore pipelines as I mentioned, laying as well as for small offshore structures. You can go for any offshore structure which is maybe in shallow water depth you are planning to go for. So, you can go for shallow geotechnical investigation for those kinds of data. Just collect the soil sample, determine its strength characteristics and soil properties from laboratory investigation, and then based on the obtained result you can go ahead with your execution part. Then comes deep geotechnical investigation, which are particularly used when we are going for maybe high load bearing structures, or maybe for exploration rigs you can go for, or maybe bridges can also be there which may require deep geotechnical investigations at the site. So, it consists of in situ investigation, because everything has to be done in situ. So, nowadays again when we go for geotechnical investigation, there are two ways: either you can do the testing from the vessel itself, or you can lower down your testing assembly at the sea floor, and from there onward you can start your drilling, sampling and testing everything from sea floor itself. So, the entire operation can be controlled from the surface vessel or control unit by means of cables or other medium, or you can do the testing from the vessel itself. So, both options are available simultaneously, which people are practicing nowadays. Then sampling. So, this is like consisting of in situ investigation you can do from the vessel which is available at the sea surface, or maybe at the seabed itself. So, this is like when you are doing any kind of sampling from depth of 120 meter or more. So, this 120 meter or more is the depth below seabed. So, it is not the depth of water, it is rather depth from the seabed downward which you are interested to explore. So, this is generally classified as detailed geotechnical investigation. As I mentioned, these kinds of investigations are generally required when we are laying foundation, when we are going for exploration of oil repositories, or for laying of jacket platform or oil rigs into the sea. Again, for design of anchor for these kinds of things, or particularly when these are not floating characteristics rigs, rather it is fixed or direct supporting to the seabed, you have to go for this kind of depth. So, samples collected from deep geotechnical investigations are used for extensive laboratory investigations, which are again done offshore itself, and are generally done for fixed and mobile platforms. So, fixed platform means which are directly transferring the load to the seabed. So, in that case, considering the load of overcoming structure is too high, so you have to go for deeper investigation. If you are going for anchored system, like in case of floating rigs, you can go for comparatively shallower investigations, but more common in offshore platforms. Then shallow geotechnical investigation. So, these are generally limited in depth. So, whenever we are trying for shallow geotechnical investigation, as I mentioned, the depth is generally limited to few meters, again depending upon what are the method you are using for sampling and what is the characteristics of the medium at the sea floor. So, this is generally limited to few meter depth. You cannot go for 50 meter, 80 meter like that, based on your shallow geotechnical investigation, because the objective here is just to know about what kind of soil, what kind of strength characteristics, or maybe in terms of chemical composition also what kind of medium characteristic is available in shallower depth below the seabed. So, every time in case of exploration if I am giving the dimension, that is with respect to the sea floor and measured downward. Then specific drilling assembly are not required here, because you are only interested in few meter. So, you can use probably the kind of sampler which are specifically designed for sample collection in offshore environment, but specific drilling is not required in this shallow investigation. The sampling of sea floor, seabed soil, as well as sampling of water which is available at different depths are also collected, so that you can get an idea, okay, minimum this is the characteristic of your seabed material as well as water which is available in your environment. Now you start going, if required, now you can start go for detailed investigation, or in case you have to provide anchor or maybe your foundation corrections or modifications. So, this gives you an idea about environmental baseline survey, what is on an average soil characteristics and water characteristics which are available. So, general understanding, it will be useful for about the site and its environment. Then any typical shallow geotechnical investigation, because you have to just collect the sample from seabed. So, at a particular site of observation, it generally varies from few hours, I mean 2 hours, maybe 4 hours, like that. So, that you can just collect the soil sample or seabed material sample from your tentative site, then probably you can move to next site. As I mentioned, like this kinds of investigations are more commonly practiced in case of pipeline along the proposed route of the pipeline. So, you can do these kinds of investigation, sampling, bringing the sample into the laboratory, do the strength characteristics, then go to the next site which may be few hundred meters away from the previous location, and so on you have to do throughout the pipeline alignment. So, it is generally used for those kind of investigation. Then vessels used for sampling must be anchored. This is more important, because if you are collecting the soil sample, and by the time if the vessel itself moves, there can be two things. One, like your connecting cable between your sampler as well as the vessel may break, or sometime if your vessel is not properly anchored, you may end up in misinterpreting the findings with respect to your location. It may be you have collected a sample from somewhere, but by the time you have collected a sample and brought it to the surface, the vessel, if it has moved, you will end up in assessment of soil properties to some other depth or to some other location. So, that is why anchoring during sampling is very much required. Anchoring, what it will do, it will actually prevent any kind of lateral movement of the vessel, particularly during sampling. So, it is usually done along the proposed route of the pipeline, as I mentioned, because it is a continuous structure which may be laid for over hundreds of kilometers or maybe more than that. So, you have to ensure that the safety at every anchor or every support system where you are planning to provide against lateral stability of pipeline, you have to go for these kinds of shallow investigation. As well as I mentioned, if based on your shallow geophysical investigation or based on your geotechnical data, if it is going to give you an idea, like your there is a possible fault along that. So, in order to ensure that the design of support system should be such that any possible movement it can do, it can withstand without any significant settlement or any kind of safety compromise with respect to the pipeline system. That can also be get a useful input from shallow geotechnical investigation. Again, it is conducted at an interval of maybe 1 kilometer, or if it is there is too much of variation in topography or too much of obstacles are there, you can actually reduce the spacing of shallow geotechnical investigation interval, or as specified by the expert. Generally, experts might be having again understanding about a particular area in terms of obstacle, in terms of topographical changes, in terms of geomorphological changes also. which are adding more and more complexity to your foundation medium, or which are adding more heterogeneity to your continuous foundation medium. Sometimes codal provisions are also available, but those are again region specific. So, one can consult those kind of codal provisions before going for deciding how many number of tests in 1 kilometer, or how frequently these kinds of shallow geophysical geotechnical testing has to be done can be determined. So, anchored system, as I mentioned here, like suppose this is your vessel, which is generally used for investigation, which is actually, so it is like, if I see here, it is like something like this, which is available in the sea bed, I mean floating on the sea floor or sea surface, or this is mean sea level, this is vessel, and this is your depth, sea bed. Now, you are interested by means of vessel because everything is filled with water, sea water. So, every time you collect a sample, minimum this particular depth has to be bypassed before you actually come in contact with any kind of possible medium from the seabed. So, this is a vessel, again I am seeing this in side elevation maybe. What I meant to say here, like whenever, so it is like whenever you are lowering some kind of assembly for sampling, maybe from here, in order to ensure like this vessel should not move in any lateral direction, like even perpendicular to this. So, there will not be any movement in this direction or in this direction. So, in order to ensure this, generally you actually go with anchoring this vessel. Same way you can have anchors here. Now, this anchor will ensure almost no movement will be there in any direction, and it will also ensure no lateral movement, of vessel, as well as or as well as minimal change in vessel position due to what? Due to wave currents or due to waves. So, because of wave fluctuation, wave height fluctuation. So, again because it is sea, so again there will be some kind of waves here, which at times I mean there will be rise in wave disturbance created by the waves. So, it can again cause some kind of movement in the vessel along the in vertical direction. So, this will also ensure, these anchors in all 4 directions will also ensure there is minimal disturbance in vertical direction, because it will have direct consequence on sampling method or the characteristic of the sample, or it will induce more and more disturbance to the sample. So, there are 2 primary objectives here: no lateral movement of the vessel during sampling, otherwise error with testing location, and minimum change. So, this will minimize error or disturbance in collected sample. Now, we discussed like, okay, offshore environment is there some variation in obstacle or topography is there for which you go for detailed investigation. Like then we have to collect samples, because finally you bring some sample onto the in your laboratory to go for maybe determination of moisture content, in situ density, or strength characteristics, soil classification itself. So you have to have some kind of sample in order to characterize the medium in detail based on laboratory investigation. So sampler for shallow investigations, the type of samples, the types of samplers used include, so you have grab and box sampler, you have drop and vibro core sampler, and then you have drilling and piston core sampler. These are primarily kind of sampler which are used for sampling from the shallower depth. Now let us see what grab and box sampler is about. So the grab sampler, again grab and box, the basic phenomena remain same, but the way it is collecting the sample, it varies between grab and box sampler. So the grab sampler, it consists of spring loaded clamshell jaws in pair. So there will be like two clamshells which are attached to the sampler at the test location, where actually you are interested to collect the sample. The sampler is lowered from the vessel to the seabed. Upon contacted the seabed, so once the sampler comes in contact with the seabed, what happens? The clamshell which were locked in position by means of spring arrangement will actually be released, and as a result of which these clamshell will actually move and get locked at the bottom surface. So the jaws which were open like this, this is the condition at the bottom of the sampler. When you are lowering it, the sampler from the vessel, as soon as it comes in contact with the seabed, the spring will release the clamshell, and then once the clamshell or the jaws comes in contact with each other, it will get locked. Now while lowering, it gets locked or shut, and then simultaneously, because again these are having tooths, these are having teeth at the lower end, which will actually scratch the material, and thus simultaneously scratching few inches, or depending upon the seabed characteristic, even sometime in half a meter or more than that, it can scratch the seabed material. And because it is after shutting down, or it is locked from the bottom, so there is no place actually the soil sample can further go. You can bring the sampler onto the surface. That is how it is also containing the sample into it. So this is called as grab sampler. So just like anything you are actually grabbing, this sampler is also going to the seabed and then grabbing this thing and bring it onto the surface. That is why it is called as grab sampler. So upon withdrawing the sampler to the vessel, the sample is collected. So that is how you can collect the sample from about the seabed material. However, one important thing here is sample obtained in this way are classified as highly disturbed, because you yourself can understand, while collecting the sample, it is actually scratching, it is inducing some kind of external disturbances, as a result of which the sample which are collected from grab sampler are highly disturbed in nature, and that is you cannot use it for determination of the strength characteristics. Now this one I am telling, like this is your sampler, this is your connecting cable, so this is your seabed, and this is somehow it is coming from vessel. Now it is having this kind of assembly which are called as clamshell jaws, which are right now not in locked position, but as soon as it reaches the surface, what will happen, these jaws will be released. So the sampler will remain like this, but your clamshells will come in contact with each other and it will actually close from the bottom. So, this movement will be happening from this particular depth. So, initially it was in locked position up, and once you release it, so this is like, I can call it as seabed material. So, whatever depth it has actually scratched, it will be depth of scratching or collection of depth of scratching into seabed medium. Depth of scratching into the seabed medium, that will define collection of the sample. So, this is like the sample which is collected here. Collected sample will be contained inside. Contained inside. Now, let us see the box score. Again, as I mentioned, the fundamental concept remains same, like each of these are actually collecting the sample from the seabed by means of one or the other arrangement. So, the box core, it consists of a box, as the name suggests, with open base. So, the bottom is open. Upon lowering the box, which is open at the bottom, when it touches the seabed, it actually penetrates into the seabed material. So, the cutting plates provided at the bottom, which were actually locked position. So, cutting plates which were in actually locked position will, while lowering, are released by means of mechanical system, as well as a result of which it will actually cut the material which is collected at the bottom and also contain the sample which is collected by that particular depth, thus cutting the sample from the bottom. So, it is like you lowered the sampler which was open. As you lowered it, it might penetrate, it must penetrate a certain depth, and once it has penetrated, by means of mechanical arrangement, a cutting assembly, a cutting plate will come, which will disconnect the contact of sample which is within the sampler and the actual seabed material and contain it inside. And then you can the sample, you can shift it or slightly you can bring it onto the surface, onto the vessel, from where you can actually go for detailed laboratory investigation. Now, obtained samples in this particular case are relatively less disturbed in comparison to grab sampler or grab box sampler, and thus it can be used for determination of in situ density, moisture content, as well as strength characteristics. So, whatever sample you have collected, you can actually use it for necessary laboratory investigation, because that's how you will be able to get an idea about what kind of medium is available beneath the surface, what is its strength characteristics. Again, here we see here, so it is like the sampler again here, which was actually bottom was open, but as soon as it comes in contact with the seabed, so there will be some kind of cutting assembly something like this assembly. So, when the material upon getting inserted to a particular depth into the seabed, this cutting assembly, you can call it as mechanically controlled cutting assembly, it will actually cut the material. So, the sample will contain the sample, and the sampler will contain the sample. This is box core sampler, and it is connected to your vessel. So, once it has cut, and this is actual seabed material. Upon collecting, you can bring that sample which is no more in contact with the blade, So, there will be some kind of box also here which will be actually inserted into the material. So, this mechanical assembly will actually provide some kind of cutting here at this particular location like this, and it will lock it here. So, that there will not be any chance that the material which is collected in the box sample will be again coming back to the will remain there at the seabed. So, this is about box core. As I mentioned, like in comparison to grab box, the box core samples are relatively less disturbance. Then comes the drop core, which is also one of the widely used method. So, it consists of hollow steel tube which may be 6 to 8 meter in length, 100 mm outside diameter, 85 mm internal diameter, with a cutting shoe is there at the bottom, and a core catcher. So, core catcher, the purpose of core catcher very much similar to your auger, it is like to retain the collected sample within the sampler itself, so that you can bring it onto the surface for necessary field investigation. So, this steel tube, which is 6 to 8 meter in length, is having a weight of 800 to 1000 kg. So, self weight itself is too high. So, you need not provide any kind of external loading mechanism, rather you can simply lower this tube from the vessel into the sea floor. So, it is like free fall. Once the drop core is dropped from the vessel to the sea floor, because of this impact load, it will insert into the sea floor by a certain margin or certain depth, or it will penetrate into the seabed, and then core catcher, by means of core catcher you can ensure the collected sample will not be remain there, but it will retain within the sampler. So, withdrawing by means of core catcher means only it will ensure that the sample should not be left at the seabed itself, but it will come along with the sampler. So, it is again bring back onto the surface, from where you can actually do lot of detailed investigation. The other one is vibro core, which is very much similar to the previous one, that is drop core, but only thing in drop core you are actually pushing the sampler into the soil by under the impact load because of cell weight of the pipe. In this particular case, you are actually pushing it into the soil by means of some kind of vibration which are electrically driven. So, you are lowering the sampler or the tube into the sea by means of electrically operated vibrations, as a result of which it will actually penetrate into the seabed, and then you can bring it onto the surface for necessary investigation. Remember, like some of these sampling methods may give you highly disturbed sample which can be only used for soil classification. Some may give you relatively less disturbed sample, so you can use it for strength determination, also moisture content, in situ density determination. But so far box core has only given you chance of highly undisturbed sample. Grab, vibro, and the drop core, all the three gives you highly disturbed samples. So, these cannot be used for strength determination, that has to be keep in mind. Then seabed piston core, by using a piston assembly. Now, in this particular case also you put the sampler into the seabed by means of a cutting shoe at the bottom, but the beauty in this particular case is, while withdrawing the sampler, see most of the time whenever it is with respect to grab box, whether it is with respect to vibro core or something, you are actually imparting some kind of disturbance into the soil, so that first of all it will penetrate, and second thing, while bring it onto the surface, you are providing some kind of cutting shoe or maybe steel plate, which is also inducing some kind of disturbance into the collected sample. However, in this case you are actually keeping the sample intact, and in order to ensure the sample should not fall down from the sampler onto the seabed, you actually use some kind of suction pressure. So, this piston assembly will ensure the creation of a suction pressure to retain the sampler into the core, and that is how the sample collected by means of seabed piston core are relatively almost no disturbance is there or minimal disturbance is there. So, you can use the same sample for collecting the for determination of strength characteristics, for understanding the soil structure and as well as for other properties also. So, this is considered to be more appropriate than the earlier discussed methods. Now, we discussed so far about a shallow investigation, which are primarily used from few inches to few meters into the seabed. Now, when we go for detailed deep geotechnical investigations, of course, we are interested to go for maybe 50 meter, 100 meter, more than that, or maybe 120 meter. So, the methods which are used for geotechnical investigations are more or less same, like we had used cone penetration test, then dilatometer test, then you can go for vein shear test. So, method remains the same, only thing the minimum depth of exploration starts after bypassing the water depth. So, from vessel, whatever method you are using, either you are doing from the surface assembly or vessel level, or you are actually lowering the entire assembly to the seabed, and from the seabed onward in the downward direction you are actually doing the test. So, primarily objective for deep geotechnical investigation is strength determination in offshore environment, particularly the seabed material or the material which is below the seabed, by means of CPT test, vein shear test, or dilatometer test. In last couple of decades, DMT has also been proven very accurate in terms of strength determination for offshore environment. So, in vein shear test, the vein is pushed, again this more generally practice is like lowering the assembly onto the seabed, and from there onward you can do the test. So, the vein is pushed into the seabed, and the torque which is required and the corresponding rotation are recorded. As we discussed in case of onshore also, like what is the rate in which the rotation has to be done, and the torque which is required to ensure that particular rate of rotation is recorded. And these two things will help you in understanding the shear strength characteristic of the material, because the sample in which you are actually inducing torque, it is undergoing shear failure. So, that is how you can determine the in situ shear strength characteristics using vein shear test, even for offshore environment. Now, when we go for CPT test, so there are two widely used method. Again, in CPT test, more common practice is to do the test from seabed itself. So, the entire assembly will be installed at the seabed, or will be there at the seabed, and from there onward you actually start pushing your rod. And if you recall, in case of cone penetration test, we precisely go for two measurement. One is like cone tip resistance, and the second one is your skin friction or sleeve friction. And at times, if you are having some kind of transducer behind the cone tip, which can also be used for determination of pore water pressure, that arrangement is also possible and practiced in many of the setups. So, the first one, so this CPT test, which consists of 2 to 3 kind of typical leadings, and as we mentioned, like CPT, unlike other methods, gives you a continuous profiling in terms of cone tip resistance, in terms of skin friction or pore water pressure. So, this is the advantage. Only thing, in case of CPT you do not get any sample. So, the test which more specifically we are doing from sea floor downward can be done in two ways. So, in first method, you can actually push the cone into the seabed by means of wheel driven assembly. So, there is a wheel driven assembly which are actually, so two sides of the drilling rod, there will be some kind of assembly which may be wheel assembly, which will actually ensure continuously pushing of the sampler into the drill rod into the seabed, which is first lowered to the seabed from the vessel. So, you lower your assembly to the seabed, your wheel assembly also, your drill assembly also, and from there onward actually it will push into the seabed, and that is how you can get an idea about how much is the cone tip resistance or skin friction or sleeve friction, and pore water pressure. This is one method. So, upon rotation of the unit, that is wheel assembly, the CPT rod is pushed into the seabed. In second method, CPT consists of, in this particular case, the tube, the rod is pushed by means of a tube, the tube is wound around the reel. So, in order to push the CPT to the deeper depth, you can actually unwound the tube, and then the tube will be straightened by means of other assembly, and then it is pushed into the seabed. So, that is how also you can measure the typical information about the seabed. Now, the measurement of cone tip resistance, sleeve friction as well as pore water pressure can be done at every depth or continuous recording, both. The DMT dilatometer, as I mentioned, it can be done from the surface assembly by means of mounting on jack-up platforms, which is almost like fixed platform from which you can do. So, any possible fluctuation in water level will not affect your DMT measurement, similar to your onshore investigation. In second, like you are doing the DMT test by means of barge, you have to provide a kind of guide tube that will compensate or that will minimize any possible fluctuation in the wave heights on your the reaction provided to your testing. Further, while taking the measurements, every time when you make measurement like applying pressure for 1.1 mm disturbance or pushing into the soil, every time when you are taking measurement, you connect your push rod with your pushing assembly. That will ensure your field measurements are minimal affected by fluctuation in water height. That is most important when you are going for fluctuating platform, particularly the barge. So, for more detail, one can go for LUPI 2009. So, DMT can also be performed from seabed itself. As I mentioned, most of the geotechnical investigation either you can do from vessel control or you can go with seabed control. You can do the test from seabed. So, when you are doing it from seabed, you have some steel frame which will ensure some kind of anchoring of the assembly with respect to the seabed, and then you will have steel plate which will be there to provide reaction towards pushing the rod into the medium. Now, last thing is like vessel layout. Everything like whether we go for DMT, whether we go for CPT, whether we go for vane shear test, every test or even for sampler also we are using a vessel. So, what is a typical vessel? Vessel is like kind of relatively bigger boat or ship kind of assembly, but it is precisely designed for this kind of investigation. So, not every kind of boat or ship can be used for this kind of assembly. The typical layout consists of a drilling derrick. So, drilling derrick is basically a steel tower which is more precisely used so that you can actually lower, because your depth of exploration will be very high. So, you can actually start your drilling assembly, drilling operation by means of a drill rod which will be significantly higher. So, you can actually erect your drill rod through your drilling derrick, and then as the drilling progresses it will keep on lowering. So, it consists of a frame tower which is 20 meter in height, located at almost the center of the vessel. Then you have moon pool, so which is basically a hole through which you can lower your drilling assembly suspended from your for which you had provided drill derrick, and to the seabed. So, this is connection or opening within the vessel which is precisely for lowering any kind of drilling or exploration assembly to the seabed. Heavy compensation assembly is provided so that whatever drilling you are using, it will have minimum effect because of possible fluctuation in your water table. So, in order to ensure that the drill cable undergoes relative movement with respect to the ship rather a fixed movement, because the ship itself will have some kind of relative movement or fluctuation. So, in order to have minimum disturbance to the drilling assembly, you have to provide heavy compensation assembly. Then you have pipe rack, which is actually an assembly where you can actually stack all the pipes which are particularly used for drill, which can be utilized in drilling. Then mud mixing assembly, where you can actually put your drilling fluid which has to be circulated continuously when you are going for any kind of drilling. Then communication and positioning system, these are very much required in case of any assistance in case of emergency, as well as positioning system, because it is very much important. You should know at which particular depth or which particular position you have done the test, because everywhere water is there. So, this positioning is very much important. Then powerhouse, because you have to have continuous supply of power in order to do the test. Laboratory, detailed laboratory, where you can actually test what kind of sample you have collected, even for storing the sample collected from different depth. So, laboratory, which is again in situ or at the vessel itself. Then anchors, to ensure no relative movement of the vessel, particularly while driving. Otherwise, there will be breakage in your failure of your drilling assembly as well. So, this is a typical setup. If we go, it consists of this is last slide here. So, you have some mud tank, you have pipe rack, then you can have some kind of moon pool here, which is assembly. And on this moon pool only you can actually see this is moon pool, this opening, and then this is like steel frame or derrick assembly, derrick drilling assembly. Then you can have your laboratory, then you can have your communication or positioning assembly, positioning assembly. So, these all things I have shown here in plan. So, these all are the must requirement whenever you go for any kind of offshore geotechnical investigations. So, with this I stop here. I hope today's lecture has given you very elaborate information about how we plan, how we go for sampling as well as geotechnical investigation in offshore environment. Thank you so much.